Hi, thanks for sticking around to the end of the day for my presentation on learning from past designs to improve habitat enhancing features of bank repairs. My name is Sam Diaz. I'm a senior engineer with cbec Ecoengineering, and I'm going to describe a study that was performed by cbec and GEI for Safeco to review existing bank repair designs, evaluate their performance, and to develop a conceptual template for future bank repairs. The problem is one we're all familiar with. Flood management agencies are faced with the challenge of repairing erosion in a manner that provides habitat for endangered species. Erosion repairs and protection against future erosion are often most efficiently addressed by adding a layer of rock to the bank. But this impacts habitat. It requires removing existing vegetation that may have provided essential shade over the shoreline or in-water habitat. Um, It introduces larger, harder substrate to the bank and precludes further vegetation growth. This is not going to be favorable from a resource agency standpoint. So what we understand is that our designs will likely need to include features to reduce the impacts associated with the repair, both in the near term and the long term. Previous repair designs have not been especially successful at establishing and sustaining vegetation, especially at the water's edge. We're talking about SRA habitat, shaded riverine aquatic habitat, that is essential for providing shade and cover and structure at the water's edge. That's the focus of our study. While some of the sites that we observed were more successful than others, in general, we found the sites to be a little too high and dry, like you see to the left here, with very spindly and sparse vegetation after the several years of growth that they had seen. And we want to make sure that these habitat design features don't just provide mitigation for construction, but actually create valuable habitat that is going to provide a meaningful contribution to the recovery of species of concern, such as Chinook salmon and Delta smelt. So we designed our study to gauge the performance of existing sites. Our goal was to determine which specific site features benefit or may be limiting establishment of sustainable SRA habitat, and then to design a template for future repairs. Um, our study involved a topographic and qualitative survey of existing repair sites to collect geometric data to document the site design. And also, there was a vegetation health and quality survey. And then we took the data from those two surveys and evaluated it to understand the links between design and performance at establishing vegetation. Now, we must acknowledge here that there are a lot of factors that contribute to the success of a restoration site after it's been constructed. There's a method of installation. Was it done right or wasn't it? Um, is there insufficient plant protection, or is there robust beaver protection? How was the weather after the site was installed? Was it harsh and dry and hot, or was it nice and cool, or did you get some rains? Um, but based on our review of um, monitoring documents for some of the sites on the river, we understand that the key limiting factor to vegetation establishment is soil moisture availability. So we focused the study on the site design characteristics that would be linked to soil moisture content. So we selected 13 sites up and down the Sacramento and Lower American rivers. And these sites were constructed between 1997 and 2011, so not too far in the past. We included several types of repair designs in the study, and I'll show you the four that we included. We have a soil trench where we have a V-notch shown up top. Basically, the rock is laid down on the bank in a thick layer, and then an excavator comes back after the fact and digs a trench in it, and then soil's installed in the trench. And then an expanded soil trench where you can see there's a much more voluminous and thick placement of soil um, that requires a little bit more complex construction. There's an armored soil trench where we have a layer of soil covered by cobbles, and this was present at 2 of the sites that we looked at. And the rock soil mix bench. This is a very popular design that is implemented all up and down the Sacramento River, where you have soil-filled rock laid on the bank to protect it and to provide some substrate for plants to grow, and then that is covered up with 6 inches to a foot of topsoil. And there were 7 of those sites that we looked at. And then we looked at one site with a rock wave attenuation bench, and there's no soil cover on this rock bench. It's just there as a wave break, but there are large woody debris habitat structures anchored to that bench. And there is a large volume of soil placed on the bank behind the bench to rebuild it and to accommodate dense planting. So in our survey, we were looking for characteristics that would promote soil moisture, as I said. Elevation of soil with respect to water, thickness of soil, continuity of soil, and the soil characteristics. At each site, we collected elevation data on the rock face and the bench, and along the bench we probed to determine the bottom of soil. And we subtracted the probe depth from the ground elevation to get the bottom elevation of the soil placement. When we looked at the substrate, we were focused on the material type. Was it a sandy type of soil, or was it did it have a clay or silt content? And this gives us some idea as to the ability to retain water and the capillary action in that soil. And we also looked to see if the soil was continuous or if it had voids. We checked out the aspect of the site. Was it north facing with large trees to the south that were shading out the new plantings, or was it on a south bank getting baked in the sun, or was it somewhere in between? We looked at the river planform setting to determine how that could be affecting the success of the site as well. And this is a simple diagram of our data workup. You can see here how we calculated the distance to water. We took elevations along the surface, we probed the soil, and then we got the elevation to the bottom of the soil. And here you can see our average bottom of soil elevation. And then we calculated the design water surface elevations. Our water surfaces were derived from a 30-year record of flows on the Sacramento River and gauge data. And on the Lower American River, they were based on our hydraulic model, which is calibrated based on extensive survey data for low flows and habitat development. We compiled all of our data into a matrix and then compared the scores from the vegetation health survey to the measurements for the parameters that we took in the physical characteristics survey. And then we identified trends between the measured physical parameters and the vegetation success. And based on the 13 sites that we evaluated, the sites that did best were the expanded soil trench design with very thick soil that was installed to depths below the summer water level. The soil over rock design did well in places. There was one example where the average soil thickness was about 1.5 feet, but that was not always the case. In most of the cases, they had about 6 inches to a foot of soil over the rock. We found that soil continuity was very important, and sites where voids were observed had thin branching vegetation that was less dense. And even in the most successful sites, we found that back of bench vegetation was drought stressed, and this is due to the increased separation between soil and water. And linking results to site design, we found that soil trenches had the potential to grow larger, more mature vegetation over time. We associated this with the inherently large volume of soil in these sites. It's good for rooting, it's capable of being deep and in contact with low water and giving roots a lot of room to roam. We found that rock soil benches had less robust growth, and we associated this with reduced soil volume at those sites. Um, Basically, there's a thin veneer of soil on top of a rock soil mix, and where you have a rock, you don't have soil. So the rock volume is not able to hold water. You have less soil for the roots to grow in. And in general, we found that all these bench elevations at the rock soil mixed benches needed to be lower to get them more in contact with the water in the dry months of the year. Now, the most successful example of a rock soil mixed bench was on the inside of a bend, and it had a very mild approach slope or very flat slope approaching it. And it had the ability to, it had established a lot of vegetation at the water's edge. And we think that maybe that mild bench approaching the site um, had the ability to induce wave breakage before the wakes hit the shore and really had all their power to erode soil off the face of it. Um, we certainly noticed that on sites with steeper banks, the soil had been eroded away much more quickly from the water's edge, and there was no vegetation present on the water side, at the water's edge. Um, with the wave attenuation rock bench, it did have rapid establishment of dense vegetative growth behind the bench. The wood structures that were anchored to the rock bench um, were subject to vandalism and rapidly deteriorated. And since this is um, only one example of this design that we evaluated, um, and the results were mixed, we think it needs further evaluation before we promote it for use in our recommended designs in the future. So basically, we are fairly aligned behind the soil trench design in our approach to creating a design template. So a few years down the line from installing our new bank repairs, we want them to look similar to this. With lots of in-stream structure, you can see tules and in-stream woody material at the water's edge and healthy vegetation overhanging the water. So with that in mind and based on our findings and borrowing elements from what we found to be the most beneficial features for creating and sustaining SRA habitat, we developed this template for erosion repairs. Now, this template is particularly tuned to the Sacramento River. And on the Sacramento River, wave wash due to boats is a primary erosive mechanism. So you can see we've got resistive rock faces protecting soil in a couple locations. And these rock faces extend up 3 feet above average annual low water um, to protect against, average annual high water to protect against boat wakes and wave runup. The riparian bench you can see is of the expanded soil trench design, and it has a large volume of soil to promote robust tree growth. The bench is very flat, as you can see. This is sheltering it somewhat from wave erosion. And the elevations of this bench are variable. So the bench will, as you go down the river, you'd see a very mild sinusoidal pattern of elevation gain and loss on that bench. And this would be intended to increase habitat complexity and also to promote design resilience. This site has a wetland bench. As you can see, this is located about half a foot below average annual low water, and that's to keep it in the water year-round, providing in-stream habitat. There's in-stream woody material here as well to provide in-stream habitat, and this is located about a foot below the average annual low water, and that is intended to keep it out of the cycle of repeated wetting and drying, which causes wood to rot quicker. And we've also included flag branches, or you want it located that is close enough to low water to provide flag branches so that river users are aware of its presence. Now, it's important to note that this is kind of the Cadillac design for bank repair, and you're not going to be able to employ this at all sites. So it's kind of a toolbox. It showcases all the elements of bank repair in the manner that we wish to portray them or include them in a bank repair design. Depending on your site, you may not want to employ all these features. As you can see here, there's a lot of rock that's required to support these benches. And depending on your programmatic needs, that may cause too much impact, or that may be too expensive. One thing we're concerned about is impact to benthic organisms due to this large amount of rock. So where you have a slope like this, you may want to reduce your habitat features, such as in this design, where we know we have a steep slope, so the habitat features are limited to just a wetland bench. And the wetland bench provides the in-stream habitat that is typically removed when you implement a bank repair. So that's one reason why we would recommend including the wetland bench if you had to pare down to just one type of design element. And here you can see you've got a bank that's steeper than 2:1, and that rock prism extends out into the bed of the river. So, as I mentioned before, based on the economics of your program, the site conditions, your mitigation needs, and your needs to avoid impacts to habitat, these repairs need to be tailored. And in some cases, you can provide a relatively large amount of benefit for a little amount of rock. You can see here we have a flat slope, and we're able to create a large riparian bench planting area that is connecting the riparian soils to the bank soils. So this is one way that you might optimize your selection of habitat elements in a repair design. So to summarize our recommendations from our study, we found that soil trenches have the potential to provide a significantly thicker planting medium that benefits root growth and promotes larger mature vegetation. Soil over rock benches work in some areas, but this is very site specific. Riparian benches need to be low enough to enable plants to access the water table in the driest months. Soil trenches help to keep soil in contact with water in the summer and fall while providing wave resistance. Varied bench elevations increase habitat complexity and also provide resilience to the overall design. Flat slopes reduce runoff and erosion potential and limit exposure to waves. And of course, critical to all three of the previous recommendations is developing water surface elevations associated with both ecological benefits and erosive mechanisms at your site. Sites with voids in the rock soil mix had poor vegetation. We need to make sure that soil is worked into the voids in the rock. Fine sand is quick draining. Silt and clays promote capillary action that helps get water to plant roots and retain water for a longer amount of time. So the selection of the type of soil that's installed in these repairs is important. Oh, getting ahead of myself. Rock faces are often necessary to protect against waves and flows. It's just going to be necessary, and including features like properly placed in-stream woody material and wetland benches will help to provide nearshore cover and refuge and help soften up those rocky slopes. Waterside face plantings can also help add habitat value to a rock face. Properly installed and managed tree protection measures are essential. Allowances for pedestrian access, such as signage and gates, will help to ensure their longevity and performance. In several of the sites, we observed beaver fences that had been trampled by river users trying to get access to the water or to come out of the water. And in those locations, there was a very clear beaver browse in the immediate surroundings. So we need to make sure the beaver fences remain intact while the plants get established. And lastly, the construction methods used to implement these designs are not typical. And we need to make sure that we have a conversation with the contractor, that they're on the same page and understand the design intent. And we need to make sure that our specifications are designed and so that we get the results that we want during construction. And lastly, we need to monitor the installation process to make sure that we get the desired outcome. Now um, there are several sites up and down the Lower American and Sacramento that are currently in design and that are employing some of these ideas. And so I look forward to coming back at a future conference and letting you know how the implementation goes and um, further seeing how they fare in the future at providing increases in uh, sustainable vegetation. And with that, I'd like to say again, thank you for your time, and I'll take any questions you may have.